Okay, we are live.
Perfect. Hi, everyone. Welcome to OWASP Toronto and to our October event. We have two great speakers for you today. The first talk will be by Brian Lawrence, the Director of Solutions Engineering for NowSecure, and he'll be taking us through Frida 101, testing of mobile applications. And then we will probably have about a 5-minute break, and then we will start up with our second talk, where our own Adam Greenhill will be talking about developing an efficient reverse engineering methodology. So before we start, just a couple of quick housekeeping notes. The feedback form for this particular session is in the YouTube info. You'll see the link at the top there. So if you are interested in more events like this, or you have suggestions for next events or feedback for us specifically about these types of events, please let us know. Also, if you're going to use this event for CPE credits, please leave your full name and email in the feedback form so that we can say that you were here, right? For the next session in November, we're still deciding on a date, but we're having Elliot Elrickman back to talk about threat modeling. And then just as a note, please feel free to interact with us via the YouTube chat. If you don't get a chance to kind of ask questions as you go along, we will be pausing a couple of different times during the talk to take questions, and the volunteers will be monitoring the live chat to read out questions and so on and so forth. If you miss a piece of this talk, that's not a problem. It's recorded and will be available on the OWASP Toronto YouTube channel after this. Okay, that's it. So without further ado, take it away, Brian.
Thank you very much. So good evening, everyone. Glad to be here. My name's Brian Lawrence. As mentioned, I run our solution engineering team here at NowSecure. So for anyone possibly not familiar with NowSecure, we are a mobile application security company. We've been around about 11 years now. We started out in mobile forensics and have built from there to do mobile testing. And one of the cool things that NowSecure has is we actually have a pretty massive research team that also includes Ula, who started Frida. So I was looking in the chat. It seems like many of you are already familiar with Frida. I have the honor and pleasure of being able to interact with the guys that are building and developing this on a pretty much daily basis. Really fun, exciting kind of environment. So I cheat a lot, and I have a direct line to those guys and can ask lots of questions. So hopefully that carries through in the presentation tonight. We are going to do kind of a Frida 101. Honestly, like there's probably you could teach a doctorate level university course on Frida. I'm going to try and avoid that tonight. So Abinit, I apologize. I may not get as far as you have. I saw you mention you're using it for a while, so hopefully you do learn something here. But trying to get everybody kind of hopefully to that 101 level, just being able to get out there and explore. Frida's one of those things that you kind of have to learn for yourself, and the more you explore, the more you're probably going to get hooked. So we use it a lot for mobile application testing. Obviously, it is a toolkit. It is actually fairly agnostic to kind of what binary it's hooking into. But basically, just to give you an idea, so Frida, for those who are unaware, is a way for a security analyst or reverse engineer, a hobbyist to get into an application and get just visibility into everything that's going on within that application as a first step. And then we can actually go out there and modify that behavior. So if I'm running, and again, I'm going to stick to mobile apps because that's what I know. Some of you may have other applications, but so if I'm trying to perform an assessment or security evaluation on a mobile application, I'm going to use Frida to know exactly what's going on without having to need any code, anything like that. It's pretty black box, so we can actually get visibility into an application and then change that application, poke and see if where we can find the cracks, and see what kind of visibility we can get, and what information that we can glean from the application as it's running on the device. So really cool thing about this is, Frida just basically pokes its way into the application and becomes part of it, to give you kind of visibility that you wouldn't have otherwise. So it's become a very popular tool out in the world, for a lot of deep analysis. We're not going to get too crazy with it. My good friend Tony Ramirez from the NowSecure team is even more of an expert than I am. He actually gave an advanced training today for our customers. I'll maybe see if we can get the link to you guys as well. He went to the 401. He went straight to the core of it. So hopefully we'll be able to get that out to the group as well, and just keep learning. So the way Frida works. So basically, Frida takes Google's V8 engine. So thank you, Google, and it injects into a process. So when you run a mobile application, you basically you bootstrap into the application. You basically create a JavaScript engine inside that app. So I can run a mobile application. I can then become part of that application, and I can say, okay, I want to do these things, and you can define what you want to see, what you want to do, how you want to respond to different activities, behaviors, inside of that application. You can define it all using JavaScript, which everybody, it's pretty out there. Everybody is usually pretty familiar with it. So I can use Frida to get that visibility, and then I can write scripts to basically say, okay, if we see this behavior. So as an example, if I see the application try and make a network connection, security analysts would love finding problems with network connections. We'd love seeing those that exposed data, bad configurations, all those great, like, affects 1,000 users, affects 1 million users kind of vulnerabilities. That's a great way to find them. So we can say, okay, hey, I want to see this network connection being made. I want to know about it. I want to, and then later on we can see, hey, we can actually modify that and see what happens when we change different parameters, different behaviors from within that application. So there's 3 different ways you can actually use Frida. We're going to focus mostly on injected here today. So there's a couple different ways to inject into the application. One of our favorites, we like to do testing on iOS applications without necessarily needing a jailbreak. So we actually we use something called Frida Gadget. We've modified it pretty heavily. Thank you, Ula. And we basically inject into the memory space of an application. So when an app runs on an iOS device without a jailbreak, so for anyone who's not familiar, jailbreaks are a huge pain. They're annoying. They're time consuming. Apple doesn't like them, but they're kind of necessary for a lot of the testing and the security use cases that we see out in the world. And we want to make sure that we're getting the visibility into these applications. So one way to do that is a jailbreak, but you're dependent on jailbreak happening. It takes time to get those out, et cetera, et cetera. So what we did is we actually built a way to inject Frida into the application runtime. So it starts, Frida actually puts it on pause, says, hey, I'm going to take over a little bit of your application space, and basically becomes a part of the application, and then just starts shooting out telemetry from the application. So really, really cool application for this, really cool use case. We can actually basically see inside, from the inside, what an application is doing and doesn't even need a jailbreak. So really cool stuff. The other 2, we're not going to get into too much here today. Again, they're very much much more advanced use cases. You can actually plug Frida into the application itself deliberately, and that's a little bit more advanced way of doing things, and a little bit heavier lift, kind of from the security perspective, because we all know how much developers love hearing requests from security to do extra work. So we're gonna skip over that for today. There are a couple tools built into Frida that we want to highlight. So Frida PS It sounds fairly straightforward. It's basically just a way to look at apps and processes on the device. But it's really useful. Just as you're going through your day to day, like, oh man, what was the package date for that application? I can just boop boop boop, done. So I can see everything I need to know. I can look at the processes that are running. And this kind of provides a platform for seeing a lot of the other things that Frida can expose. So lots of cool ways to do that. Frida Trace is a way to essentially kind of get a window into an application, what it's doing at runtime. So when an application loads, it's performing a number of different function calls on the within the application. It's calling to, it's accessing files, making network calls, asking the UI to do things to get user input, things like that. So this is a great way just to say, hey, here's what's happening. Build me a picture of what this application is doing, so that I can then hone in on what I actually want to look at, what I want to accomplish. Frida Discover, also a great way of kind of just disassembling and seeing what those different pieces of the application are, so that we can actually then go back to Frida Trace and say, okay, here's what's happening. So just in terms of using Frida, just being very practical about it, as we're thinking about, hey, I want to start using Frida, what can I use it for? What can I do? Again, going to the security use cases. So the app, again, we're injecting into that runtime, so it's something that we don't need any kind of source code. So a lot of security testing out there, you do it on the source code. You say, okay, hey, I see this function, get password, and it says, oh, I'm going to get the password, and really it's just the password's 1 2 3 4 5. Well, if I'm using like an iOS application, if I'm looking at that, if I don't have the source code, I'm not going to be able to see those kinds of things. So it's a great way to understand what is going on from within the application as a security analyst, without needing that visibility, without going into the code and requiring a lot more kind of effort from an organizational standpoint. And it's just but it does require a little work. So what we'll see is we can actually build. So there's lots of testing tools out there. There's lots of things ways you can test every single application. You can do a test that looks for excessive permissions, looks for lots of different ways to do network connectivity or encryption or things like that. But where Frida really comes in and really shines is building those kinds of use cases that are specific to individual applications. So just as an example, was talking with a bank not too long ago, and they had an application that created a secure database at runtime. So you load the application, it creates the database and encrypts it at runtime. So there's nothing there ahead of time, nothing even really thereafter. But as the app's running, it has this theoretically secure location to store data. And what they did is they actually built a Frida script that looked for the encryption of that database. So it looked for the actual method that was saying, hey, I want to generate a key, I want to encrypt this database, and it actually basically controlled that output. So it said, okay, I see that happening. I'm gonna stop that. I'm gonna say, okay, because it was going to be a nice cryptographically secure key. Everything was going to be fully randomized. It'd take years and years and years, or the advent of real quantum computing to crack this. And all they did was they said, okay, I'm going to make that encryption key whatever I want. So they could change it to 1 2 3 4 5, and then they could turn around. They can actually decrypt that supposedly secure database. So that's where Frida comes in. That's what really shines, and hopefully we'll give you a little bit better idea of how that plays into security testing and the overall landscape of those deep dives and those really intense high risk security assessments. So first thing you need to do is get set up with Frida. So there's a little bit of a debate internally for us about whether we should include this in the presentation. And then as I was getting set up for this presentation, I ran into a bunch of problems. So I decided to include it. Hopefully this is helpful. and everybody finds this useful. So this again this is maybe like 100 instead of 101. So I apologize if this is a little bit basic for everyone, but Frida is really a complex, really awesome tool, but it can be a little hard to get started. So I want to make sure that everybody can in fact get started, because it really is awesome once you get going. So you need to have obviously a computer you can use and control and have admin access to. So you need Python. Hopefully most everyone is familiar with Python. It's a really cool programming language. You do need Python 3. Python 2 is even hard to get now, so hopefully that's not a big deal. We can again, I mentioned jail testing. That's a little bit down the line. So initially, you're going to need a jailbroken iOS device or a rooted Android device is the easiest way to go. So that means for most of there's a subreddit for jailbroken iOS devices. I think that's a great place to start. If you're looking to get into jailbreaks and iOS, it can be kind of an adventure. Android is actually much simpler to get that level of access to. So for, again, anyone who's unfamiliar, when I say jailbroken or rooted, that means so Android and iOS devices comes with protections in place to say, we don't want you doing things that you really shouldn't be doing that are potentially dangerous, that can potentially expose you to malicious activity, et cetera, et cetera. Android obviously a little bit more open about these things. They want to encourage development. They want to encourage developers while still protecting their users. iOS very, very much walled garden. We don't want you to see anything. We just want you to push our buttons, for the things we want you to do. Messaging, et cetera, et cetera. So when you use a jailbroken or rooted device, we have broken through those protections and gotten the access to the device that we need to be able to run Frida and run the things that we need to get the visibility into these applications. So that's a fun adventure, and we're happy to talk about that later. Putting Frida on your laptop, fairly easy. There's a Python installer called pip, and you just tell it to install Frida. And you make sure you install Frida tools as well as Frida, because that covers the base Frida as well as the tools we talked about earlier. Get you the complete package. And then hey, take a look. Make sure you are make sure what version you're running. Double check yourself. Just do a quick smoke test. If this comes back with an error, you got some work to do. If it comes back with a version, you're doing great. He just released version 14. So for any of those power users out there, please go out, get 14. It's got some really cool stuff. It's a lot faster as well. So feel free to jump on that. So to the devices, there's a release pages. So if you Google Android Frida install, it will point you to the instructions for this, and then it'll point you to this page. So the only thing you need is the type of device that you have. So if it's most any modern Android device is going to be ARM64. Some of the older ones will be ARM, and you just need to look for Frida server Android. There's going to be like 100 things on this page. It's actually kind of cluttered. Just make sure it says Frida server. There'll be a version number, Android or iOS. Either way, and then whatever kind of device that you have. If you're unsure, Google it. Just ARM or ARM64, whatever device you have. Shouldn't take more than a second. And then there's instructions on the page. So this GitHub Frida releases that has the instructions. For Android, it's just like 3 commands. It's push the file to your phone and then start it up. Pretty simple stuff. iOS. So one of the cool things that does happen when you actually do jailbreak your iOS device, it does have a really cool community around it. They've developed something called Cydia, where you can get these packages, and it's a little bit easier to manage what's installed. So you can actually just add Frida in and just hit install. Boom, you're done. It's good to go. So really, so a little bit harder, a little bit higher of a bar to cross to get the jailbreak. But then once you're there, there's actually kind of a cool community and packages around that. So good stuff there. And then you can smoke test it. So We talked actually, I'll focus on the bottom one down there. So we talked about Frida PS. When you do Frida PS dash capital U, that is going to look for USB connected devices. So when you're, in this case, hey, Android, your Android device is hooked up via USB, you have to clear any trust issues. So make sure debugging's on, make sure you've trusted the computer, et cetera, et cetera. And then it'll actually go through in a list, just a list of all the applications and their package names. So this is, again, it seems simple, but it is actually super useful for when you're going through and you're doing these tests, and you have to point to a package or a name. It's actually really, really easy. So common dumb moments. Some of this is sourced from preparing for this presentation, so take this with a grain of salt. But if you're waiting for the USB device to appear, again, just make sure it's plugged in. Make sure ADB is running. If it can't connect to, if it can't see anything, so on iOS, typically it means there's an installation problem. For Android, you probably just have to kill and restart the server. So the instructions are here for that. I won't spend too much time on it. We're obviously going to share this deck with everybody. So it's basically just kill the server, restart it. On iOS, it's a couple things you can run into. So sometimes, iOS does need a developer image on the device to be able to run. So you just have to literally load Xcode with the device plugged in via USB. Should be good to go. Another one is make sure your iOS device is jailbroken. I cannot tell you how many hours I've spent trying to troubleshoot Frida when all I had to do was re-jailbreak a device. Again, jailbreaks get lost when you have to restart a device, so it runs out of power or you restart it for some reason. Typically, jailbreaks will go away, and then you have to redo it. Frida does need that to be active in order to really function properly. So that's kind of the end of the kind of setup, intros. So I think this is a great place to pause and just see, are there any questions about kind of Frida in general? Is there anything anybody wants to see in particular? So I'll pause there, and hopefully we can get some questions from the crowd.
So Brian, there was a question earlier asking, so when you were introducing Frida, asking about version 8 and whether it's been replaced in the last build.
That is an excellent question that I don't have a great answer for. I don't know off the top of my head. I will probably kick that either to Tony if he's available, or I will have to follow up later on that one. So I apologize, but I do not have that answer. Do we have any others, or?
No other questions for now, so we can move on.
All right, sounds good. All right, so we're just going to dive in here to some kind of basic Frida commands. Again, the smoke test is Frida version, and this is not just a smoke test. This is a great way because you have to make sure that at least the major version. So as I mentioned, we just put out 14. You want to make sure that the Frida version on your computer that you're using to interact with the device matches what is the two are talking and matching up together. So it's actually kind of important to check and be aware of and know. Again, this is one of the things, this is one of those mistakes I've made before. Just to make sure that the major versions match up. Also, I just got a message. So it does look like Quick.js has been introduced with the latest build. So sorry to go back to that question, but just to make sure that got answered, You are correct. And it does look like Quick.js is the second runtime that was introduced. So good call, whoever did call that out. Thank you. All right, so some of us have multiple devices connected to the computer at any one time. I know, let's see, looking around, I've got 9 different mobile devices on my desk right now. So it can be a little bit hard to keep track of those. Might be good to know what's even connected at any given time. So this is a great way just to list all the devices that are hooked up. You might have Android devices, you might have iOS devices. Just this will give you a great inventory to look at and make sure you're pointing at the right things. Or you might need to unhook something, you might need to plug something in. All right, so once we have the device we want connected in, we can do this Frida PS. So again, this processes to it's going to list everything that's connected via that USB device. So if I have whichever device is hooked up via USB, it's going to go right in there. It's going to list everything. So this can be forewarned. This could be pretty verbose. This is something that's going to literally give you every process that's running on the device at any given time. So great way to find the process you need if you want to, but it can be a little bit of a needle in a haystack sometimes. So you might want to grep that down. So we can also add on A to this. So that will give you the running application. So rather than just every single process, we are going to cut down to the actual applications that are running on the device. So this could be a very short list, could be a very long list, depends on what you have running. But this is also a great way to identify what we might be able to attach to and look at a little bit later. Yeah, it's a duplicate. I'm going to skip it. So getting a little bit deeper here. So Frida, you were familiar with, hey, Frida, we want to do over USB. But now we want to open a particular application, or we want to do a certain thing with a certain application. So we can use that -F to spawn a particular package name. So this will actually work. So for those who are paying attention, earlier we had that list of applications and packages. You can actually use the common name or the package to refer here. So that -F, what that's going to do is it's actually going to force it to open. So if I'm just looking at my home screen, whatever, not really doing anything, if I use that -F, that is going to force that application to open, and it's going to force Frida into that application. And then the -L, and we're going to talk about scripting and a little bit of things later. We can actually use that the JS scripting in order to define what we want to do. So in this case, we are going to force open the MSTG uncrackable app, and we're going to run myscript.js against that particular application. And just a note, Frida by default will often pause that execution of the episode. It'll say open, it'll inject itself, and then it'll just wait there. It's like a little puppy dog. It's like, hey, what do I do now? No pause is just going to tell it to go. It's just to say, hey, we don't need to wait. We don't need to go. We don't need to hit that resume. And I just want you to move forward. So that pause is actually kind of nice. A lot of times, like when I'm doing testing, I'll need to instantiate maybe a couple different probes or a couple different things that need to happen. But if you don't want it, throw in no pause. You're good to go. And just to kind of work through just a basic workflow, in terms of actually performing a security assessment. So static analysis, decompiling, particularly on the Android side, it's fairly easy. Some of you may have used JADX GUI, APK tool, things like that. On the iOS side, there's cool stuff like objection, Drozer, things like that. Those tend to be more dynamic, but there's that analysis of the binary code as it sits. And we can use that. We can say, okay, you're using this library that I know I've found vulnerabilities in before, or hey, you're performing, you've asked for this permission that I don't really like that much. I need to look at that. So I'm going to look through that analysis. I'm going to say, okay, here's the things that I want to see. Then I can use that to generate these scripts. And I can say, okay, so they're using the OK HTTP library. I know that's got some issues. I'm going to write a script for that. I want to see everything that's going on with OK HTTP. Or you're using AF networking on iOS, and I want to know what's going on there, and then we can run those scripts, on the application, get that visibility, and see, okay, AF networking, hey, you flagged it to accept any certificate from anybody, anybody that can figure out how to generate a certificate can man the mill of your traffic, stuff like that. So that's typically how we think about using Frida, going through a workflow as we're testing these applications. And a great tool to do this with, kind of before you even get to writing these scripts, is Frida Trace. So what this does is it lets you go through the, you'll let the application run, and you can trace you can trace that thread. You can pull that thread and say, okay, I want to see what's going on. I want to trace everything that's happening with this particular piece of the application. I don't know exactly what I'm looking for yet, but I want to see what's happening, so I can, I'm a security person, I'm an expert. I can go in and say, okay, I want to pull this thread, I want to pull this piece, and you might want to build specific scripts to look at specific pieces later on, but this is going to give you the pieces to look at, and it's going to say, okay, here's what I need to see, here's what I need to look at. So we can trace, really cool things. So you can trace, for instance, on iOS, we can trace NSURL connections. So NSURL is the API that iOS uses to actually generate network connectivity from the device. So quick note here, because I think this is a really cool thing to really dive into. This is something we do all the time. A lot of us are probably familiar with tools like Burp, for instance, Charles Proxy, Midem Proxy. There's a couple others out there. They're great with tools to be able to test network connections, network connectivity, things like that. But they require, the traffic to kind of leave the device. So you're kind of inserting yourself, device is sending the data, you're intercepting it before it gets to where it's going, and you're decoding it potentially from there. Well, any of your Power Burp users have had probably some problems lately. That's a whole other TED talk for that, which I think Tony has actually given a couple times. But what we can do with Frida, and the real power of this tool, is we can actually look at and intercept and see that traffic before it ever leaves the device. So this is being generated at the binary level on the device. There's no proxying required. There's no you don't have to worry about managing certificates, trying to figure all this stuff out. You can actually just go see, okay, here is every network connection this application is making. And that is Frida. That is the power of Frida. Right there is just that visibility. Even before you get to modifying anything, you can see this is what Frida does. This is the visibility it gives me. This is the power that I have. So you don't have to worry about is this a HTTPS connection? Are they one of the most common questions I get is, does it matter if my application is pinning? Can you still test it? My answer is always yes, and it's because of this. And it's really cool. So I'll step off my soapbox and continue here. You can also trace things like the file system. So it's a great way to storage on the device. What am I storing and where? And there's some cool things we'll get into in a minute about this one. And then the third really big use case too is cryptography. So obviously we're in security. We love talking crypto. And we can actually trace, we can see, okay, what's being encrypted, how is it being encrypted, where is it being stored, where is it being sent? So this is a great way for Frida to give you visibility into this. And there's going to be, for any individual application, there's going to be those little tweaks, those little things that you have to account for, and that's where we start building scripts for. Yeah, the cheat sheet you guys can look at later when you all, I'm sure, are going to review this slide deck in detail. So just a couple things around differences, Frida Discover versus Frida Trace. Discover is really kind of that more high level picture of here's the individual things that are happening within the application. And then Frida Trace is where you kind of pull those threads, those individual threads out, and say, okay, I see this module is writing a lot of, doing a lot of interactions with the file system. I want to pull on that thread. And I see this module is sending a ton of network data, and I'm worried about that. Like, this module says it's from the North Korean government. I want to know, like, what are they sending over there, kind of stuff. So discovers that high level picture, traces where you pull those threads and you follow those threads. And then for discover, so again, we still use that -U switch for the most part. Hey, we want to know the device that's connected to the USB, and we're going to force open the application. We're just going to inject ourselves right in there and get started. And the output looks like this. So this is hey, and we use the OWASP iGoat application for this example. So you should see something pretty similar. So you'll see kind of at that high level, you'll see here's the module, like the individual component that's doing, performing actions. And then you'll see all of the different actions that it's taking. So in this case, and this is a very short example, as the slide mentions, this gets very verbose. It genuinely does. It can be a lot to go through. But there's also a lot of really cool stuff that happens. So we can see, like, hey, the file manager is making these calls. Common Crypto, a library we're all very familiar with, hopefully, is making these calls to perform these actions. So really cool way, again, just to identify those threads to pull on. And then we trace. So, hey, we say, okay, I saw NS File Manager. I want to make sure this application is storing data securely. I can use Frida Trace to look at NS File Manager specifically. So I'm going to tell it, hey, USB device, this is the application, and I want it to look for a specific method. So I'm going to say, I want it to look for that method that's writing these files. And what we can see is we can actually, now we're grabbing that output. So it's injecting the application, and it's saying, okay, every time that this application calls to NS File Manager, looking, reading, writing files, I want to know about it. I want to see that, and I want to say, okay, I want to get that visibility. So we're just peeling away the layers of that onion. And then we can actually get more and more specific to say, okay, I want to know what exactly it's doing. So it's okay. So it's looking for a file if a file exists, things like that. And there's some cool things you can do with file exists. So I'll give a great example. So a lot of applications will look for specific files to see if that device is rooted or jailbroken. Well, if I see that file, I see that call to file exists, I can tell Frida, be like, yeah, it's cool. That file's not there. And Frida will say, it's cool. That file's not there. And the app will think, oh no, it's this device. It's not jailbroken or rooted. It's cool. I can keep going. So we can actually extend that and say, okay, I want to look at all of those file exists, and I just want to focus in on those, and I can single those out, and I can adjust based on that. So really, really cool way. Like, again, just peeling away those layers, like really just diving into how that application genuinely functions. I don't think I'm going to have time to be able to do this live, but I do want to talk about that NSURL thing again. So, and just kind of like pull this all together and say, okay, we've looked at an application, we use Frida Trace, we see that it's using NSURL session to go through and do something. And we want to trace those network calls, and we want to say, hey, I want to look at that, and I want to say, okay, I want to look at just as NSURL sessions. I want to look at the data task of request, so I can see, okay, I want to see what data is going to and from my application. It's pretty standard stuff, but it's going to give you everything within that application, so we can actually see any kind of and we use the NowSecure app again here as an example. I can actually see the calls, the actual calls to specific endpoints. So in this case, we're like, hey, //login. Yeah, that's super interesting. I want to know everything that's happening with that, because I want to make absolutely certain that kind of stuff is secure. And you can actually even dive even deeper into that, and you can say, okay, when I see these calls, and this is where we really get into the scripting. This is how you guys are going to graduate from 101 to 201. This is with scripting. So we can actually build a script to say, okay, when I see this this particular call, I want to then dive deeper and I want to pull out that information. So I want to see what all the individual pieces of that call are. So I want to know how it's sending it. I want to know where it's sending it. I want to know the headers it's using. I want to know the body. I want to know the actual data that it's sending. So just to be clear, we can actually use this to expose all of the information that an application is sending to any source, regardless of the secure, how secure the connection is. So even if I have the best TLS implementation, I've got cert transparency, I've got cert pinning, I've got it all. It won't matter because Frida can see this on the device as it's happening before any of those things do. And I can say, okay, yeah, I'm sending username and password, sending to my auth. Yeah, it's totally secure over HTTP. I was at a bank not too long ago, and we went through a similar exercise like this, and they were, we did an assessment. They were sending their username, username and password when the user logged in. They were sending it to their auth endpoint. It's totally secure. Everything's great. And then a little bit further down, that same username and password, we're going to graph.facebook.com. So in a room full of probably 40 people that worked on this application, I just asked, hey, how many people here knew that you were sending user credentials to Facebook Analytics? And there was a bit of an uncomfortable silence at that point, and we had to put a pause on that meeting, and there's a bit of a fire drill. But this kind of gives you the idea of, this is what Frida can do. It gives you that visibility, and long term, next quarter when you guys invite us back to do more talks, it'll be Tony that time because we're reaching the limits of my expertise. But we can go into how to actually modify those things and say, okay, when this happens, I want the application to do different things. All right, so that's me. And I'll pause there to see. Hopefully, there's more questions. Tony and I will be available in the chat as well. I know we're taking a break, so feel free to ping us. We love talking about this stuff. Yeah, I'll stop there.
All right, thank you, Brian. Just looking at the chat right now. There's no questions at this point, but those of you who are in the audience, if you have any questions for Brian, feel free to type that into the chat and we'll try to get that answered.
In the meantime, I do have a couple of sort of generic questions that I think would be interesting for this audience.
Yeah, of course.
Do you have any sort of recommended reading or other tutorials you would point people to if they're kind of going from, say, this 101 to a 102?
Yeah, absolutely. Unfortunately, documentation on Frida is fairly sparse. There are a couple good places to go. So Frida does have a code share. So if you're on Frida's website, if you just Google Frida code share, there's a place for people to kind of put in common common use cases, common scripts that they've built. So it's a great way for the community to interact and kind of share things. If you're trying to do something, there's a good chance somebody else has wanted to do that too, and you can go there as well. As a completely shameless plug, NowSecure's blog, it does have some good resources for Frida and testing. Obviously, as we mentioned, we have a little bit of an advantage, an unfair advantage in this place. So we have and a couple other really, really great researchers that do a lot of really cool stuff with Frida. They write about it sometimes. So I definitely recommend checking that out as well.
Awesome, thank you. To follow up on that, then, is there anything you would recommend for people who are looking to run Frida on a non-jailbroken device, or resources for power users?
Yeah, absolutely. Again, another shameless plug. NowSecure Workstation is the way to go for that. But the thing you're looking for, and unfortunately, it's fairly new functionality. It doesn't have a lot of documentation. I don't think a lot of exploration has been done with it. And what you're looking for is Frida gadget. So I know there's been some good chatter, and actually, this is also probably a good place to plug the OWASP Slack group. So there's usually a great discussion in there. If you're trying to accomplish something, like Frida gadget has been, has been mentioned there before. That's a pretty international group of people that are probably going to be your best resources right now. There's not going to be a lot of like codified documentation, but there's a lot of people who are eager to help and have probably encountered similar problems. So I'd say that's probably your next best option.
I'll probably just jump in here and say that the OWASP mobile application or the mobile security testing guide does have some steps on how to patch the application, repackage it, resign it, in case you're trying to use Frida gadget and do the embedded solution.
Yeah, absolutely. And I know re-signing iOS applications comes up a lot. There's a conversation I think in there today or yesterday about that. So there's a couple of tools out there. And one of them is Node-AppleSign. It's open source on GitHub. I think that's certainly my favorite.
Thank you.
Yeah. Absolutely. So thank you, everybody. Please, if there's any questions, don't hesitate to reach out or ask in the chat there. Like I said, we love talking about this stuff. It's really fun, and we love to nerd out about it. So hopefully we can help.
Ryan Thompson asks, any recommendations on good sources for jailbreak apps?
Well, I'll tell you what we're using right now. For iOS 13, we're using Uncover, which is more of a Checkra is what I'm actually looking for there, and I just brought it up there. But yeah, so I think that's what we're more using right now, and. So that's for 13. I haven't seen anything for 14 yet. And then I think before then we were using what's going to slip my mind now. Of course, Electra is what we're using previously. So again, I don't know if somebody could link the Jailbreak subreddit. That's a great place to get that information on a more regular basis. All right, looks like that's it. Thanks, everybody. Appreciate you coming out, and hope to chat soon.
Thank you, Brian.
Thanks, Brian. And thank you to Tony and Jim as well. I know you are in the background there, kind of keeping track of things. Okay, so I think Brian has agreed to stick around for another 5 minutes or so, just in case you guys have questions. And in the meantime, let's take a short break, and then Adam can start his talk on reverse engineering after the break. So how about we come back at 7:30? That would be 7:30 p.m. EST. And then please stay tuned for the talk on reverse engineering. Please feel free to continue to ask questions or any of the other talk to each other on the chat as well. And Brian, if you have anything unscripted that you'd like to, that you or Tony or Jim would like to sort of mention, feel free to go ahead.
I'll also shamelessly plug Tony's Tech Talks. So Tony did, as I mentioned, a tech talk today that was a kind of a deeper dive into Frida and like really, really super deep. So we are actually planning on doing those monthly. So I would definitely, as I mentioned, we have Tony is a fantastic expert on this stuff. He also probably is like one of the most qualified people in the world to talk about cert pinning in mobile apps. And then, of course, we have Ula and Pancake, who runs Radare. So I would definitely subscribe to those if you can, and get involved in those. So that was another good thing to, if you want to keep learning about mobile application security, that's a great way. We love converting more people to the dark side.
Where can people sign up if they're interested in following that?
That is an excellent question that I'm going to defer to Jim.
Jim, if you're speaking, you're on mute.
He's probably scrambling the same way I am.
That's all right. Do you guys have information about like the roadmap for Frida in the next little while?
We don't. I have the only roadmap that I really have too much visibility into is how we're using Frida, kind of for us, which is in a much more automated fashion. So we're looking at using it to test like thousands of apps a day, which is super fun and pretty exciting challenge. But that's kind of where we're going with it. I know, Frida Gadget is a good focus where we're trying to make it a little bit easier to get in there without that jailbreak. I think we'll probably see something. I know not a lot of work has been done, frankly, on the Android side for Frida Gadget, so I wouldn't be surprised if that's coming down the line as well.
Perfect. What's the context behind testing many applications using Frida in a day?
Well, one of the cool things that we can do is we're doing it on jailbroken and rooted devices now, but we are actually pulling from the Google and iOS app stores. We're actually pulling like a couple thousand, soon to be like 20 to 30,000 apps a day from the app stores and performing security assessments on them in an automated fashion. So we have like basically an on-demand database of like, if you want to know about TikTok, for instance, you can type TikTok into our tool and it'll have, a history of TikTok security assessments. So a lot of companies use that to, help, BOD programs, things like that, just managing kind of the mobile risk within their business. So, obviously the world being what it is, with me not traveling to Toronto 5 or 6 times a year, we've become even more dependent on mobile apps, mobile devices. So it's been an interesting lift. We've been able to help some large organizations and governments with trying to address that new horizon. It's been fun.
Nice. Looking forward to seeing sort of the analytics and all the rest of that stuff that comes out of that as well.
Actually, I gave a talk at a healthcare conference maybe a month ago, where we actually pulled like 1,000 of those, 1,000 healthcare applications, contact tracing included, and we're like, did some meta-analysis on those bigger data sets. So be scared.
Feel free to drop a link.
Yeah, I'll see if I apologize to Jim for committing him to finding all these, and we'll make sure to get everything out to you guys after the meeting at least.
Perfect. Thank you so much. We are at 7:30, and that means Adam has tried out his video and he's ready to go. So Adam, do you want to thanks again to Brian, Jim, and Tony of NowSecure. Adam, do you want to take it away with your talk on reverse engineering?
Yeah, absolutely. Thank you, Ophi, and thank you everybody else for coming here. Yeah, welcome everybody to a high-level tactic for reverse engineering. My name is Adam Greenhill, and I'm a senior consultant at Security Compass. I've been penetration testing for about 4.5, 5 years now, and over that period of time, I've collected a number of certifications. And I want to highlight just the beginning of this presentation for complete transparency that neither in my professional work nor in my certifications do I have much reverse engineering experience. And that's basically why I created this presentation. So a couple of years ago, I really started to dive into IoT penetration testing. And for those of you who don't know, effectively what IoT pen testing is you get this physical device, you tear it apart, you look at the software, the hardware, you test the radio frequencies, and one of the components of testing an IoT device is reverse engineering. And as a web application and network pen tester, I found that the skill, reverse engineering, has gone from a nice to have to a necessity. So effectively, this presentation is all about my journey to become more of a reverse engineer. And I started the same way I think a lot of people do. I did the shell code, I did the exploit exercises like Protostar and Fusion, I did the Coralon training and some crack me's. So I built that understanding of assembly and various exploits. But still, when I was put in a live environment, I felt like I wasn't being very effective. I felt like I was falling down rabbit holes. I was repeating work that I'd already done. And I just, in general, felt like, I could be doing reverse engineering a lot more efficiently than what I had been doing. So I set out with this goal. And the goal was effectively to develop some kind of, general strategy to, be able to reverse engineer things quickly and efficiently. And I started with this hypothesis that, at the end of the day, whether it's reading assembly or you're reading Python and Ruby, effectively it's all the same. At the end of the day, they're just code reading exercises. So with this hypothesis, I basically dove into it. I started basically absorbing all of the information I could possibly absorb in relation to source code review. I picked a pretty opportune time to do this. Just because Offensive Security released their Offensive Security Web Expert certification. And even though it does have an emphasis on web exploits, a large focus of this certification is source code review. So in combination of reading resources related to that, I also read the OWASP code review guide. I purchased a ton of different books, like The Art of the Software Security Assessment, which I think is required reading for any reverse engineer. But it really focuses on the source code aspect of that. Another great resource is Code Reading. Code Reading is effectively a how-to manual for reading code. It even talks about this in the early chapters where even very experienced developers don't really take the time to, read other people's code, and it's, the best way to learn. Effectively, the code reading book is, if you're given a large, million-line, open source project, how can you easily read through that and understand it so that you can contribute to it? But effectively, I took all of these different source code review resources and tried to pick and choose various aspects of that would apply to reverse engineering. Because a lot of it didn't apply just because with reverse engineering you don't have architecture diagrams or manuals really about how the application was written. But I did find a lot of it still did apply. And on top of that, I wanted to highlight Seth and Ken. I've never met these two individuals, but they run a source code review training camp, and they publish a lot of really good resources online. So if this is a topic that interests you, I would definitely check out their resources and everything else I mentioned. And basically, I took all of that and distilled it into some like general advice that you can use to more easily and effectively reverse engineer software. So let's start with the obvious general advice. To the experienced reverse engineers in the audience, this will seem very obvious to you, but have to start somewhere, and maybe the new reverse engineers that are attending this talk might learn something. So with that in mind, I'll start with the fact that I find that binary analysis requires like absolute 100% focus. So when I'm reverse engineering something, I like to just remove all of the distractions from my environment. Slack, email. I'll even remove like music from my environment just because I find that it can even be distracting there. And on top of removing distractions, I find another great thing is writing things down. And this is a tip that I retrieved from a colleague of mine, and it's writing things down in a physical notebook that you can completely detach yourself from the computer that you're doing the reverse engineering. And it allows you to completely separate, in the sense that if you take breaks, and I strongly encourage that if you are taking if you are reverse engineering something, that you do take periodic breaks. Being able to physically leave your room and review your notes, and I think it just allows you to have a different perspective that you wouldn't have otherwise if you're just sitting in your one room doing everything there. And the main thing I wanted to highlight with this is the fact that you need a lot of different perspectives and ideas when you're reverse engineering, because to me, I find it's more of an art than a science. I think if you gave two equally skilled reverse engineers the same binary, I think they would come across or they would come out of it with very different understandings of how that binary works. So I think in general, you should also get other people's opinions and their feedback of how you've analyzed something, share blocks of code, etc., just to get some different perspectives there. And with that kind of general advice done, I want to highlight my strategy, because I think when I first started reverse engineering things that I was doing it completely wrong. And I think my focus when I first started doing this type of stuff was I was looking for the vulnerabilities. At the very beginning of going through a binary, I was looking for the remote code execution vulnerabilities. I was looking for the big ticket issues. And I realized that even when you have that, to some degree in the back of your mind, even when you've pushed it, back, I think it's still like this, desire, like you want to find, the crazy vulnerabilities. And so instead, I've tried to, completely ignore that, that need, and instead push for just a complete understanding of how the binary works. So prioritize comprehension over everything else, and just we'll talk about some strategies on how you can do that. So the first strategy that I think helps to obtain that comprehension is tracing inputs. And this might seem a little bit obvious to some of you, but there's a caveat that I really want to highlight, because what I mean by tracing inputs is starting at an entry point to the binary and just tracing that one variable throughout your entire application. So if you have an input like, maybe your application is reading from a file or taking from an environment variable, or even just, retrieving a command line argument, effectively take that variable and just go as far into the program as it, is consumed. Going into function, into sub-function, whatever you need to do. Because the goal is that you understand at a very intimate level how this variable affects the program. And one thing that I will keep bringing up in this presentation is not getting sidetracked. And I'll cover a little bit why in a moment. Because strategy 2 is really looking at, instead of a variable level, looking at a function level. And the idea here is that you start at the top of a function and just work your way down. If this function calls other functions, you just ignore that and just try to understand how this function works in its entirety. You can note down what functions it does call, but just ignore diving deeper for now. And you might ask yourself, okay, how come I can't just freely dive into a binary, looking at all of these different things, all at the same time? And I find that, in doing that, at least for me personally, I lose track of context of why things were called, where things were called, etc. I find that this was one of my main issues in the beginning. When I would just freely dive into a binary, I would just, I would get overwhelmed. And I think having a clear-cut strategy of, hey, I'm only going to look at a variable, or I'm only going to look at a function, I feel like this is this really helps to provide some kind of guidance when you can very easily just lose yourself in a sea of assembly. And the goal here, at least the strategy that I kind of came up with regards to reverse engineering, is that over time you're slowly putting together the pieces. You're slowly understanding what variable A and what variable B affect the program, and what function A and function B, how those are used in the program, and then you kind of just reassemble from that. You kind of have these understood building blocks that you use to understand what this binary does. And so that's really the main strategy. And there's also a couple of miscellaneous tips that I picked up from the resources that I mentioned earlier. And I think the biggest one that has helped me is something called desk checking. And the thing with this is that it really helps address one of probably the most intimidating parts of reverse engineering, which is when you find a super large, complicated block of, just an algorithm that's written in the assembly that has a ton of nested loops and a bunch of if statements, and it's just doing all these weird mathematical calculations. I find that to be super difficult to process. So the thing that can help with that is desk checking. And what effectively it is where you build out a table of inputs and outputs. And the inputs will be every single variable, variable A, B, C, D, etc. And then, your resulting output. And the idea here is that you're just picking random inputs for each of those variables. You can try to do a little bit of fuzzing here by picking large negatives, large positives, 0, stuff like that. But, it really doesn't matter. And the idea here with desk checking is, you're not trying to see how the application that you have, uses this algorithm. That is for another time. Your entire goal is just determining what this specific algorithm does. So you're not concerned about if there's input validation that would maybe prevent a negative number from getting there, or things like that. Your entire goal is just throwing whatever inputs at it to really, at a thorough understanding, understand this algorithm. Because again, the whole point of this is to slowly build up understanding of large components of the application to assemble a complete picture, instead of trying to understand the entire application all at once. You're breaking it down into more manageable parts. Some other miscellaneous tips that I have here are related to, a dependencies. So looking at what kind of libraries that your binary is using, that can be very helpful. Also considering the operating system that your binary is built for, because Windows, Linux, the embedded operating systems, they all for instance manage files a little bit differently or handle memory buffers a little bit differently. So keeping all of that in mind will help you maybe put some things into context and help you understand the application a little bit more. Another couple of tips would be hypothesis testing. Now, this is more of an advanced technique to help you kind of speed up your reverse engineering. And this is where you take a look at a function and looking at the system calls that are performed or the system functions that are used, and basically taking a wild stab in the dark as to what's happening. Like if a socket is being created, if it's binding to a port, you can kind of assume what kind of network activity, or you can assume that network activity is being performed here, and you don't need to go line by line looking through the assembly to prove that. You can obviously use stuff like dynamic analysis to verify that, but effectively you're just trying to speed up the process by making estimated guesses as opposed to the tedious process of doing it line by line. And the last miscellaneous tip here is to reread and revisit. And that is because, as you develop more understanding of how your binary works, you want to make sure that the new information that you have, is built on solid assumptions, and that it hasn't, the new information that you have doesn't invalidate the information that you found previously. So it's always helpful to, just double check that everything is working as you expect it to, and, you can just verify that continuously. And the last thing that I'll talk about, this is a fairly short presentation, but the last thing that I'll talk about here is practice, because I find that, the resources that I linked in the first couple of slides where, that are typically given to somebody who wants to learn how to reverse engineer, I just don't think are sufficient to, when somebody uses that and then goes into a live environment where they have to reverse engineer things, I just think the gap is pretty severe. So I'm going to recommend some like real world situations that will help you understand the skills that you need when you have to do it for real. And that is effectively, practicing against real software. Now, I definitely encourage anybody who has an interest in doing this to definitely take a stab at, Firefox and Google and, Microsoft Office and, all of the big AAA software. But if that's too intimidating for you, I also recommend that, you can go on to ExploitDB and find some like large software, some maybe like old or, like legacy software that has exploits, and then reverse engineer that. Because if there were previous vulnerabilities found, then there are likely quite a bit more of them. And it might seem overwhelming at first, but that is what you're aiming for. You're aiming for the moments where you are a little bit overwhelmed, that there are, it feels like millions of lines of code, and that's what you're trying to get practice, diving into. So with that in mind, that was really it for me. Like I said, pretty quick presentation, but thank you everybody for coming. Are there any questions or concerns?
Hey, thanks, Adam. Do you have any other tips or like resources that you found valuable when you went down this path that you could share?
Honestly, I feel like I covered a lot of it, but I think the thing that I didn't mention in the presentation would be perform continuous like practice. Like I talked to a bunch of colleagues about reverse engineering, and we all agree that this is a skill that deteriorates very quickly. So if you're not actively doing it, like I find that it just goes away very quickly. Unlike web application pen testing, which I feel is very easy to just pick up again after a few months of not doing it.
Okay. Any favorite tool sets that you would recommend people look into?
Yeah, for sure. I think Ghidra is good. I have the Ghidra book right like on my desk here. Haven't read it yet, but there's a Ghidra book. And yeah, I don't know.
Nice. Doesn't look like there are any questions specific in the chat right now. Shall we give it a couple of minutes? Anything that didn't make it into your deck that you would have liked to add if you had some time?
Yeah, I mean, so I guess like in terms of reverse engineering, I know that I made this presentation to be like pretty, I guess like goal agnostic, just in case people wanted to do like malware reverse engineering. But I highly recommend the Coralon exploit development course. I think Peter, the author and the trainer, is very good. He definitely knows his stuff very well, and I highly recommend it if anybody has the opportunity to do that. I think there's also another big course coming out. It's from a Hong Kong-based training company, and it's supposed to be like a modern exploit development course. I've heard good things about it. I haven't taken it myself. I'll see if I can find that.
Okay, cool. If you do find it, please post it in the YouTube chat, and then we'll try to collect some of these links and resources that were talked about today to post with the sort of wrap up of this session. Let me just copy some of that right now. Okay, well, if there are no further questions and nothing left from the audience, thank you all for attending. It was great to see you all, and welcome to all the new people who came for the first time, and to all of our returning chapter and other participants. Thanks again to Brian Lawrence from NowSecure for introducing us to Frida, and to you, Adam, for this talk on reverse engineering methodologies. To anybody in the audience, please don't forget to leave your feedback in the feedback form. It's the first link in the description of this video. And thank you to our sponsors who let us hold these events and help us to fund things like pizza normally when we have these in person. So the sponsors would be Security Compass, HPE, Checkmarks, AWS, Shopify, and Sonatype. So thanks again. Hopefully we will see you at the November event. We have yet to schedule it, but we will be announcing the exact date once we have confirmation from both speakers about what it is on the meetup and via the mailing list per usual. Right now, the speakers who are scheduled are Ellie Elrickman from sorry, where is he from? From Synopsys, yes. And he'll be talking about threat modeling, and hopefully we'll also have Connor McKinnon in to talk about Security Champion. So again, that notification will go out as soon as we have the exact date nailed down. So thanks again. Hope you guys all have a good evening. Any last minute add-ons from the team here?
No, thank you all for coming.
Thanks, everyone. Have a good night.
Thank you.
Take care.